Question 7 says, in a dilute gas at pressure P and temperature T, the mean time between successive collisions of a molecule varies with T as. Now, the mean time T naught can be given as the mean free path lambda divided by the average speed V average. And we know that the average speed is directly proportional to the square root of temperature. That means T naught is proportional to lambda divided by root T. And if you look at the options, it matches with option 3. Let us now go to question number 8. Question 8 says, a student measuring the diameter of a pencil of circular cross section with the help of a vernier scale records the following 4 readings: 5.50 millimeter, 5.55 millimeter, 5.45 millimeter and 5.65 millimeter. The average of these 4 readings is given as 5.5375 millimeter and the standard deviation is also mentioned. The average diameter of the pencil should therefore be recorded as. Now, if we look at the options, one thing is there, except option 2, all other options have more than 3 significant figures. Option 1 has 5 significant figures, option 3 has 4 and option 4 also has 5 significant figures. And if we look at the data given, it is clear that we can only record up to 3 significant figures. So, that helps us zero in on the answer and option 2 is the correct one. We do not really have to go into the standard deviation and others because other options are ruled out because of the number of significant figures. Let us go to the next question now. And question 9 says, a particle moving in the xy plane experiences a velocity dependent force F, which is k Vy I cap plus Vx j cap, where Vx and Vy are x and y components of its velocity v. If A is the acceleration of the particle, then which of the following statements is true for the particle? And the options are, the first option says quantity V dot A is constant in time. Option 2 says kinetic energy of the particle is constant in time. Option 3 says quantity V cross A is constant in time. And the fourth option says F arises due to magnetic field. Well, let us evaluate the different options and if for example, we consider quantity V dot A is constant in time, if we look at the situation here, acceleration is given as k Vy I cap plus Vx j cap divided by m, the mass of the particle, is it not? The velocity of the particle is Vx I cap plus Vy j cap. So, if we look at V dot A, what are we going to get? V dot A will be then Vx I cap plus Vy j cap dot k divided by m into Vy I cap plus Vx j cap. That is what the question statement is. Now, if it says that it has to be constant in time, it would mean that we have to have k by m into Vx Vy plus again Vx Vy, that means 2 Vx Vy is constant. Now, we have no reason to believe that this is going to be true as such. So, we can't really pass on judgment about this option at this stage. We can say that we have no basis to assume that this is going to be constant. Coming to option 2, kinetic energy of the particle is constant in time. Now, if that was true, then the dot product of the velocity and acceleration should have been 0, which is not necessarily the case. It is not coming out as 0. So, option 2 is ruled out. Similarly, if we look at option 4, F arises due to a magnetic field. If this had been the case, then the dot product of the force and velocity would have been 0, which is not the case. So, we need to evaluate option 3 also. V cross A is constant in time. So, let us find the expression for V cross A first of all, and if we look at V cross A, what we are going to get is, you know, Vx I cap cross Vx j cap. That means Vx square, that term will be there. There of course is a term of k by m, and I cap cross j cap is k cap. If we start with, you know, V cross A is constant in time, we are going to evaluate this. So, we are getting Vx square k cap, and then again Vy j cap cross Vy I cap, that will give us Vy square minus k cap. So, we have Vy square minus k cap. So, this should be constant if V cross A is to be constant. Okay. Let us evaluate V cross A. Let us evaluate this term now. What is Vx square minus Vy square coming to? So, now according to the question, the x component of acceleration would be k Vy divided by m. That means we can write dVx by dt is equal to k Vy divided by m, and similarly the y component of acceleration, which is dVy divided by dt, is given as k Vx divided by m. Now, we can divide one equation by the other, that will give us dVy by dVx in terms of Vx and Vy, and after that by integrating we get the relation in fact that Vx square minus Vy square is coming out as a constant. Well, that means we have now arrived at the solution to the question, and it means clearly that the quantity V cross A is constant in time. So, option 3 is correct for question number 9. Let us now go to question number 10.